It says let f r to r be given by fx equal to a polynomial x minus 1 into x minus 2 into x minus 5. And capital Fx, another function is defined as integral 0 to x ft dt where x is greater than 0. So capital Fx is equal to, capital Fx is integral 0 to x ft dt. Ft is what? T minus 1 into t minus 2 into t minus 5 dt. And the domain of the function is x greater than 0. This is the function. Now it is given that f has a local minimum at x equal to 1, local maximum at x equal to 2, number of local maxima, local minima, and fx not equal to 0 for all x belongs to 0 to 5. First of all, we need to check for local maxima and minima. So let us go for the derivative of the function. So f dash x is equal to, differentiating by Leibniz rule, you will get x minus 1 into x minus 2 into x minus 5. This is the derivative of the function. Now, if we analyze the sign of this derivative by wavy curve process, this is going to change sign at 1, this is going to change sign at 1, this is going to change sign at 2, this is going to change sign at 5. And what is the sign of the expression? If I take a value more than 5, say somewhere here, some value here, more than 5, then if we substitute in place of x, it will be positive, positive, positive. So it will be positive here, it will change sign at 5, it will change sign at 2, it will change sign at 1. So the wavy curve will be positive, negative, positive, negative. So we know that from the left to right, the derivative changes sign from negative to positive is a point of local minima. And where the derivative changes sign from positive to negative, that is a point of local maxima. So we got from the graph negative to positive sign change at 2 points. So we can say local minima at x equal to 1 and 5. Local minima at x equal to 1 and 5, and positive to negative sign change. So local maxima at x equal to 2. Local maxima at x equal to 2. So we can answer the first question. F has a local minima at x equal to 1, correct. F has a local maxima at x equal to 2, correct. F has 2 local maxima, 1 local minima, that is wrong. It has 2 minima, 1 maxima. So option C is wrong. And option D is Fx. Option D is Fx is not equal to 0 for all x belongs to 0 to 5. For that, let us do one thing. Let us calculate the value at 2. If we calculate f2 value, which is the local maximum value, which is the maximum value of the function, local maximum value, let's calculate the value f2. So f2 will be integral 0 to 2, we will put x equal to 2, 0 to 2 t minus 1 into t minus 2 into t minus 5 dt. So this will be equal to integral 0 to 2. If we open this up, it will be a cubic polynomial t cube minus sum of the root, that is 1 plus 2 plus 5, 8 t square, plus sum taken 2 at a time, 1 into 2 plus 2 into 5 plus 5 into 1. So 1 into 2 plus 1 into 5 plus 5 into 2, that is 17t minus product of the root 1 into 2 into 5, 10 dt. So if you integrate, it will be t power 4 by 4 minus 8 t cube by 3 plus 17 t square by 2 minus 10 t. Put the limit 0 to 2. 2 substituting, we will get 4 minus 64 by 3 plus 34 minus 20. 0 substituting, all 0. So if we club these 3 terms, we will get 18 minus 64 by 3, which is minus 10 by 3, and that is a negative number. So at 2, the function is at a negative value. And clearly, from the wavy curve, we are confirmed that what is the domain? Of course, the domain is given as 0 to 5, right? So within the domain, if you analyze from 0 to 5, function is initially decreasing up to 1, then increasing up to 2. At 2, we have a local maximum value. And that local maximum value at 2 is a negative value. If the maximum value is negative, that means what? Function is always negative. All the remaining values are negative, right? So roughly we can sketch the graph. say at 0 it will be at 0. Of course it is 0 at 0. It is 0 at 0, right? Then up to 1 the derivative is negative, so it will decrease up to 1. Then 1 to 2 derivative positive, 1 to 2 it will increase, here 2, but at 2 the function value negative, then 2 to 5 it will decrease, 2 to 5 it will decrease. So function will always remain negative within this particular interval, open interval 0 to 5. Okay, so option D, fx not equal to 0 for all x belongs to open interval 0 to 5 is correct.